Hello everyone. So today I'm going to talk about something called self-querying retriever that is available in LangChain. And to explain what it is, I want to take some example. So when you're doing a search in a search engine, you basically put in some keywords and that's it. I mean, that's how you usually search. But when you're asking the same thing or something very specific to a chatbot or an AI, you give it a lot more context, or you tend to explain a lot more things. So here's an example. Let's say you would ask a chatbot, what was the article shared by someone, first name, last name, about AI safety, right? And what you want, basically you are looking for, the search item is this, but this extra piece of information, like article shared by someone specific, that's actually a filter that you want to add to narrow down your search space. Otherwise it will just try to search across everything, right? Here's another example. What was the article shared by Febin on PTech Learning channel about building AI coworker personality? So again, the main search is building AI coworker personality, and there are other extra filters, which is who shared it and in which channel they shared it, right? Another example here, what was the message shared by Ish about marketing for AI products about a week ago? So the two filters here is who shared it and around what time, and the actual search query is quite limited, right? So you want to do this. One of the reasons that you want to do this is to narrow down your search space and to improve the quality of your search and improve the relevance of that search result. So I'm going to talk about quickly, but before I do that, here's a diagram as well. I want to show a quick demo for the same. So if I take this, I made this small API to execute this tool. I basically made this search query as a tool for the agent that we are building. And I gave this query, what was the article shared by Vinit Agrawal about AI safety? And when I click send on this thing, the result is already here. You can see the actual query is about AI safety, and this it has figured out that it has to put a filter, which is a equal filter, which is EQ means equal filter, and attribute is from, because this is the modifier that Slack uses. Basically, I want to use this filters in the Slack search API, and the value for that from value is Vinit. So basically the name of the person for which you want to do the search. If I take another example, and put it here, and do a send again. So this is what are the articles shared by Febin on PTech Learn channel about this specific topic. So you can see here it has actually done quite a lot of things. It has figured out that the person is Febin with the from modifier, and the in modifier, which is in which channel it is talking about. It has also figured out that, and there is a and relationship between both of these, and it has also figured out the query itself, right? So it is able to do quite sophisticated things. So as you will see, this format that you see here, this is called structured query format. This is the format used by LangChain in a standard. It's a standard LangChain format which it converts to, and then from here it takes to a particular web store or vector store equivalent translation. And if I give another last example, what was the message shared by Ish about marketing for AI products about a week ago? So it is able to find that as well. It is able to even see the date, and compare is less than, and the actual query is marketing AI products. So yeah, though this is the demo for this, I will now go over to the diagram and talk about how it works. So you get this natural language query, which is it can be quite elaborate. It can have a lot of these extra hints about what are you searching for. You give it to a LLM with tools, which is basically an agent in this case, and this is the tool it chooses right now. It has this is called a self-querying search tool. I'm calling it Slack's self-querying search tool. So it will turn a natural language query into this structured query, and then it will make the actual search. So it takes the basically inside this tool, if you look inside the hood, there is something called structured query constructor, where you have to provide a lot of information about what the Slack search works, how the Slack search works. So if I take to this help doc, you can see it has these modifiers like in, where it limits the search in a particular channel or particular conversation, from, which limits the search space, basically searching for messages from a specific person, and similarly the other as well, before, after, all those things. So I have given these information in the form of attribute information, which I'll show the code for it as well. It turns it into and it runs this query constructor, takes this information and takes the natural language query that was provided by user and turns it into a LangChain structured query. This is something I showed you in the Postman demo. And then from here, it goes to something called query translator. So this is the standard LangChain structured query format, and it has to be turned into a specific query format for different database. So if you are searching inside VV8, then you have to turn into this particular format into a VV8 specific query, right? In this case, we have to turn this into a Slack specific query. So this query translator has to be built for Slack. So this is something right now I'm working on, and this will take this information, take this structured query and turn it into something like this, which will be a modifier based search query. And then with this search query, we can do a Slack search API call and get the final result. So this makes sure that whatever we are searching for, it is very narrowed down, and it is actually aligned to what you're actually looking for. So coming to the code itself, this is how the code works. So I've tried a bunch of experimentation, very simple code relatively. You have to just provide the attribute information. So in this case, the first attribute is the in parameter, which searches for messages or files in a Slack public channel. I gave some example. I even mentioned it that if a user puts a hash in front of it, just ignore it and just only get the actual name of the channel. Similarly, I have also mentioned in DMs, which is a more minute details, which is you can even search for a specific DM conversations. And then third attribute is from, search for information shared by a specific person. Example, marketing report by Febin or product roadmap by Emmanuel. So basically this is the names of the people, and date information as well. So I have to define each attribute that I want to extract from the natural language query and define it and describe it so that the LLM can understand. So this is how the main part of this piece work. And then I'm just running it through a query constructor, getting the query, and this is a structured query here which I'm returning. I'm also trying to figure out to do this translate query. Right now I just tried it with VV8 and it is working because it comes out of the box. So this is a translate query, but I want to do the same thing for Slack. So I hope in the next video I'll be able to show something around that, or maybe something else. So this is the part how it works in the code. Finally, if I show you, this is the place to go. This is the LangChain's self-querying documentation. It explains things in a very nice manner. It gives some example as well. So in LangChain, they have explained it primarily the self-querying in the context of when you're searching for vector search, but I'm extending this whole idea to a bit more general idea, where I'm actually using Slack's its own search API. It's not a vector store, but it is doing one thing, which is it is converting a natural language query into a bit more structured query using the modifiers like from and in. So that actually is a bit different implementation or use of this specific idea. But definitely I would recommend to go through this specific page, which will give you a lot of good idea about a good understanding of how to get started and build something which works for you. And that's pretty much it. I hope you like this video, and looking forward to making more of these. Thanks a lot.